Hello guys, if this is your first time joining us on this channel, of course I am Sir Peter, and this class is proudly sponsored by LearnLift. Oh yes, LearnLift is primarily focused on the fact that you must succeed at all costs. Are you getting me? So all your classes in your chemistry, physics, biology, mathematics, your English, your GSS, every singular courses you are offering, irrespective of the department that you are, every singular class is well catered for to ensure that your success is smooth and sweet. Guess what? Oh, your A's, they go loud. Oh yeah, follow me. In this class, we are going to be focusing primarily on what is called the basic concepts of set theory. Mathematics is very simple. There is nothing difficult in it. I'm going to be taking you step-by-step procedure on everything about your set theory, but this class will focus on your basic concepts of set theory. If you are not yet subscribed to this channel, it's very simple. You are not paying for subscription. Just click on the subscription notification bell so that you are subscribed to this channel, and then anytime we drop classes, you are the first to always receive the classes directly from us. Oh yeah, let's go. So in our basic concept of set theory, we are going to look at a lovely and a whole lot of stuff. I'm going to give you a total of 20 things to note in your basic concept of set theory. So number one stuff you must know is called the definition of sets. Oh yes. So if you are to define set, how do you define set? It's very simple. Take note of this very quickly, that your set is a collection of distinct elements. So the collection of distinct elements is called set, or the collection of well-defined objects is called set. So what is set? It is the collection of distinct objects, or the collection of distinct elements, or the collection of well-defined objects, or the collection of well-defined elements. This is called set. Again, what is set? The collection of distinct elements or well-defined objects is called your set. Now, this is it very fast. You must know this, that it is defined by listing its members within curly braces. So how do you define set? Every member of a set must be within curly braces. These are what we call your braces. Is different from your brackets or your parentheses. No. You don't go and say set and then you are going to put your set in something like this. You are wrong. Or if you go and try any of this, no, that is not set. This is wrong. This is wrong. This is the correct one. So what do we use for set? Curly braces is what we use for set. So you must write it, practice it, and ensure you are writing it perfectly well. So it's like this. Are you with me? Now let's go, guys. Now, e.g., if I have 1, 2, 3, now you can see how are we placing them? All of them are within that curly braces. So your curly brace, then you have your 1, you have your 2, you have your 3, and then you close your bracket. Your brace is very, very simple as that. Another thing is this: each of these distinct objects that is within it is called an element or member of the set. So that's what they call element or member of a set. For example, let me say I have my set A. My set A is probably like my 1, 2, and then your 3. Now, what is 1 there? 1 is an element of the set. 2 is an element of the set, and then 3 is an element of the set. Again, don't forget, what is set? Set is defined as the collection of distinct elements or the collection of well-defined objects. That's a simple definition for set. We're going to 20 of these basic concepts. Let's go. Number 2 that you must note is called the elements or the members of a set. So when we say element of a set, what does it also mean? It also means members of that particular set. Are you getting me now? How do you define it? Take note. An element or member of a set is an individual item or object within a set. So individual item or individual object within a set is called what? The element of a set. Now, you must understand this very quickly, that for instance, let's say we have set A, and set A is 2, 1, 3. Let's say our set A, for instance, that we have gotten here, our set A is your 2, 1, 3. Now the question is this: what are the elements of the set? Of course, we can say 1 is an element of set A, 2 is an element of set A, and then 3 is what? An element of set A. That's why we say 1 is an element of that set. Are you getting me now? So what is an element of a set? It is the members or the individual items or objects within a set. That's what we call element of a set. Another name for element is called what? Member of a set. Now, catch this for me. The order of the set does not matter. No. Now, let's say, for instance, we have something like this. Your 1, 2, 3. your set A being 1, 2, 3, and then your set A being your let me say your 2, 1, 3. They are the same. These two sets are same. Why? Because the order in which they are coming, it does not matter. Another is this very fast. If an element is repeated several times, now for instance, let me say they ask you what is the element, how many elements do we have in this set? Let's say the set B is your 1, 3, 5, 7, 5, 1, 3. Now, how many elements do we have in this set? You see, a lot of people are going to fail this very fast. If an element is repeated several times, it is only one of such elements that is considered. Only one is what is considered. Are you there with me? So if I have, for instance, 1, 3, 5, 7, 5, 1, 3. Now, please position this for me properly. What is it going to give me? You have 1. How many times is 1 occurring there? It does not matter. 1. What do we have there? We have 3. What do we also have there? We have 5, and then we have what? 7. Are you getting it? So how many elements do we have there? 1, 2, 3, 4. There are 4 elements there. So the number of times that the repetition is taking place, it does not what matter. Are you with me? That's what elements or members of a set. Number 3 has a sweet name, and number 3 is called membership of a set. There is membership of a set. You belong to a family, you are a member of that family, you have membership in that family. So what is membership of a set? Simply put, very fast, membership of a set means an element belonging to that set. It means the element that belongs to that set. So that is membership of a set. Now, another thing you must note very fast, it is denoted by the symbol E like this, like your E. So if they write something of this nature, what it means this guy is a member of that set. And of course, membership there is more like elementship. If there's something like elementship, nothing like that anyway. So membership of a set is nothing but like elements of that set. Are you getting me now? So that's why it is denoted by this symbol E. Now let me shock you. For example, if A is 1, 2, 3, then we can say 2 is a member of A. You can say 2 there is an element or a member of A. Are you seeing it? It's as simple as that. Another thing is this. Since 4 is not an element, so if I look at this, for example, the set A, our set A, we're giving set A to be your 1, 2, and then your 3. The question is this. Is 4 part of this set A? No, 4 is not part. So since 4 is not an element of the set A, how do you represent it? Simple. You want to just say 4 is not an element, or 4 is not a member of the set A. So this is how it is written. So if you write the symbol of elements like this or member, and then you cross it, what does it mean? It means it is not a member, or it is not an element of that set. You must understand this. So I'll be on you back to back. Why? Because there is that burning desire in our hearts to ensure that you succeed. Are you with me? Let's go. Number 4, very quickly, it has a name. Number 4 basic concept, it is called the methods of specifying sets. So what are the various methods of specifying sets? There are a lot of methods used to specify sets, but we're going to focus on just 2 of them that are very, very key and cardinal. So take note of this. Sets can be specified in several ways, but we will focus on 2. Now, what are the 2? Number 1 is called the roster or the listing method. When we say roster method, another name for roster method is also called your listing method. So within roster or listing method, elements are listed within your curly braces. Are you getting me now? For example, let's say we have something of this nature, the set of vowels in English language. Now, what are the sets of vowels? Let's say the V there represents vowel. And what are the vowels? We have A, E, I, O, U. A, E, I, O, U, E, E, A, E, I, O, U, G, G, A, E, I, O, U. Now, the sets of vowels in your English are E, I, O, U. Of course, where are they? These guys here, if I represent it this way, what do we call this particular method? This method of specifying sets is called roster or listing method. In other words, we have not done anything, we have only listed. Are you getting it down? You say V, there is what? Your A, E, I, or U. That's your roster or listing method. It's not like, for example, in every class, they are sweeping rosters. Back then in secondary school or primary school, they are sweeping rosters. If it is your turn to sweep the class, of course you sweep the class, right? That roster, every turn by turn, That's how it is represented. The second way you represent set is called your set builder notation or the rule method. What is it called? Set builder notation or the rule method. Now, in this method, what happens? Elements are defined using property. So, a set builder notation, elements there, they are defined using property or rule. For example, let me show you very fast. We say the set of even numbers is, let's say the E there is your even numbers, and the set of even numbers E is your curly braces X. This slash here is the same thing as like this, either this or this, they mean the same thing. So it means X is such that, or X is such that, anywhere you see it is the same thing. X is such that X is what? An integer. X is an integer, and of course you know that in your integers we have what is called your positive integers and your negative integers. Your integers are nothing but your positive or negative whole numbers. Are you getting me now? X is so that X is an integer, and then they now went further to tell us that an X is an even number. X is an even number. So are we dealing with negative integers here or positive integers? It doesn't matter. Now this is it. But we are dealing with the ones that are even. Are you getting me now? That's what it represents. That is your 2, 4, 6, 8. That's for the positive integers. While for the negative integers, what do you have there? Negative integers are going to have something like your -2, -4, -6. Are you getting this? So that's it. Take note of this. If you see anything of this nature, this method here is called your set builder or your rule method. Are you with me? Now let's go. The number 5 as a sweetening. Number 5 here is called subset. Under the basic concept number 5, you must know is called subset. When we say subset, what do we refer to as subset? Subset, inside set, in the inside. Are you getting me now? Subset. What do we mean? Simple. A set A is a subset of set B if every element of A is also in B. That's the definition. A set A is a subset. That means set A is inside set B if every element of A is also in what? In your B. It's simple. Let me show you something. It is denoted as A there. A is less than. If you watch, this is not, it is like this, not like this. Are you getting me now? Like this is more like your less than. Are you getting it now? But this guy is now facing like the less than location. What it means? It means that A is a subset of B. You see that I write it like this, I'm correct, or you say A is a subset of your B. Now, what is the difference between the first one and the second one? The difference is simple. For this first one here, it means that your A is not equal to B. A is a subset of B, but A is not equal to B. This second one means that A is a subset of B, but A can also be equal to your B. Are you getting me? Let's go gradually. I'm going to catch all of these things very well. Example. Let's say, for example, we have a set A, and the set A there is, let me call it your 1, 2. And then we have another set B, and the set B there is your 1, 2, 3. Now, be with me very fast. What can you say about this? Is A a subset of B, or B is a subset of A? Which one is inside the other? Of course, all the elements of A, 1 and 2, they are inside your set B. Therefore, you can say that your A is a subset of your set B. Are you getting it now? That means your A is a subset of set B, because all the elements of set A, they are inside your set B. As simple as that. But if you watch, 1 is lacking, 3 is not inside this guy. Are you getting it? So I cannot come and put equal to here. Simple. The word is enough for the wise. Go over it again and again. You see that it's very simple to understand. Now, number 6 quickly that we're going into, on that basic concept, number 6 is called your superset. When they say superset, what does it refer to? Take note of this very fast, that a set B is a superset of set A if every element of A is also in B. We have sub, now we have super. A set B is a superset of set A if every element of A is also in B. Let me break it down for you. It is denoted by every element of A is also in B. It is denoted by B here is a superset of A. Are you seeing it now? Let me break it more. B there is a superset of A. What it means is that every element of set A is in your set B. Which one is the Oga set? Like, which one is the bigger set? Which one is the one that is more like above? The one that is higher is your B. B is a superset. If you watch, we are not using, anytime you use less than or equal to like this, not less than or equal to, I'm one, it's not like this. No, it is rather like this. If I use like this, what is it? It is subset. If you now turn it to be this way, what is it? It is your what? Your superset. Are you getting me now? Now look at this very fast. Example, we can say your set A, let me say set A here, or let me say set B is your 1, 2, and then 3. And then we have another set, your set A, we say our set A is your 1, 2. Now what can you conclude from here? You can say that 1 is a subset of the other, while 1 is a superset of the other. What it means is this: your B there, we can conclude by saying from this, we can conclude by saying that your B is a superset of A, or A is a subset of B. Are you seeing it now? So the two of them, just understand when you are using one and when you are using the other. Now the next, quickly, basic concept number 7 is called the proper set. When we say proper set, we have subset, we have superset, we have proper set. When we say proper set, what do we mean by proper set? Very simple. Follow me very fast. A set is considered proper if it is not equal to the universal set. i.e., a set is said to be a proper set if it is not equal to the universal set. Now let me explain. A proper subset. So there is proper subset. A proper subset is a subset that is not equal to the original set. Now let's say, for instance, we have our set, our universal set, to be, let me say, we have our universal set to be anything but, let me say, odd numbers. If universal set is odd numbers, what can you say there? That means it will be 1, 3, 5, 7, 9, like that to infinity, right? Oh yes. And let me say your set A here, is let's say our set A is 3, 5, 7, and that's all about set A. Is it right to say set A is a proper subset of the universal set? Oh yes. Why is it so? It is so because every element of A is inside your what? Your B. A set is considered proper if it is not equal to the universal set. So the set A is a proper set because the set A is not equal to the universal set. Now, a proper subset is a subset that is not equal to the original set. The set A is not equal to the what? Original set. So we can say A there is a proper subset. It is your set A is a proper subset of the what? Universal set. Are you with me now? The next, very quickly, we're going to consider here, that's number 8, is called your proper subset. Let me explain proper subset more in details to you. Take note of this very fast, that Y is a proper subset of X if every element of Y is also an element of X. Are you getting it now? Understand this with me very fast now. Y, your Y is what? A proper subset of X if every element of Y that is inside Y is an element of X. But this is the difference now. But there exists at least one element. There exists at least one element of X that is not an element of Y. At least there is that one element that is inside X that is not an element of Y. Okay, let me explain again to you. Let's say our set Y here, set Y, we have agreed that our set Y is your A, B, C, and then D. We say Y is a proper subset of X. Now, your Y is this, and then your X here is our A, B, C, D, and then E. Let's take these two. Which one is a proper subset of the other? Of course, Y is a proper subset of X if every element, you can see all the elements of Y, if every element of Y is also an element of what? X, also an element of X, but there exists at least one element that is not an element of Y. Only on that condition you can say that it is a proper subset. You know, somebody will now ask, what if, for example, it is not just E that we have? There is E, there is F, there is G, and then there is now H. Then you now close the brackets. Is Y still a proper subset of X? Oh yes. At least all you are looking for is at least there should be one element that distinguish. That does not mean that F, G, and H, they cannot come in place. Of course, they can come in place very, very well. So you catch your proper subset now, right? Oh yes. Let's go. Hold on a bit. As far as 100 level is concerned, right, for both first and second semester, your complete series of classes, including your practicals, everything from beginning to the end is in the LearnLift app. All you have to do is just march down to your Play Store or App Store and download the LearnLift app, and then you're going to have access to every singular class. So just move down to tertiary, click on tertiary plan, where you are going to see all your classes as far as your 100 level is concerned. And guess what? Your video lessons are there, your CBT is there, you have access to your past questions, you have access to your notes. Very, very important. Man, this semester you must do well. Anyway, let's proceed quickly as we march down to our class and continue our class. Enjoy. Now, take note of this. The proper subset is denoted. Your proper subset is that your Y is a proper subset of X. Now, let me explain something to you. You can't say Y is a proper subset of X and you go and write it like this, that Y is a proper subset of X. This is wrong. Because what this means is that at least your Y is a proper set of X, but Y can also be equal to X. No, there exists at least one element of X that is not in Y. So rather, proper subset is represented by just this alone. Simple, and you are out. Then next, quickly, number 9, you must hold tight. It is called equality of sets. When we say equality of sets, what do we refer to as equality of sets? Let me tell you something. There is what they call the principle of the first. How you take this semester is what determines how you take the rest. In fact, how you take this semester is what determines how you take the next semester. How you take the next semester determines how you're going to take the rest. In other words, you must be deliberate about your success. You must be intentional about the level of the A's that you should have. Nobody need to come and cajole you to take learning serious. No, you must be intentional about it. You must be deliberate about the classes. If you wait for your lecturers, you are going to waste. That's the truth. Just be consistent on the classes back to back. Are you getting me now? Of course, we are here for you. No, don't play. As you go to learn. What do we mean by equality of sets? Equality of sets is something that is very simple. From the name equality, it means there is that equal. Are you getting me now? But let me explain it to you. This is two sets A and B are considered equal if they have the same elements. So two sets are only equal if they have the same element, meaning that A is a subset of B and B is also a subset of A. Are you getting me now? Two sets are equal if they have the same elements. So the elements in A are also in B. The elements in B are also in A. But there is no element that is in A that is not in B, or there's element in B that is not in A. No. Two sets are equal when their elements are what the same. Now let me show you. It is denoted by, of course, what denotes it by your equality sign. Are you getting me now? Another thing is this, e.g., let's say your set A is 1, 2, and 3, and then we have set B to be 3, 2, 1. Can we say these two sets are equal? Oh yes, set A there is 1, 2, and 3. Your set B is the order in which they are coming does not matter. In as far their elements are the same, the two of them are said to be what? Equal. So what can we conclude? We can conclude that our set A and set B are equal. Why is it equal? Because the elements in A are also the same elements in B. We have 1 here, we have 1 here, we have 2 here, we have 2 here, we have 3 here, we have 3 here. So they have the same elements as their sets are what? Equal. Then number 10, very quickly here, under your basic concept, is called finite set, your finite set or your finite set. Finite. So when we say finite set, what do we refer to as finite set? It's very simple. This is it very fast. A set is finite if it contains a countable number of elements. In other words, you can count it. What is it? Finite. If you can't count it, what will it be? Infinite. A set is finite if it contains what? Your countable number of elements. Let me show you something now. E.g., set A. In our set A here, set A is your 1, 2, and 3. Now the question is this: how many elements are in set A? You can count. This is 1, this is 2, this is 3. So the number of elements there are 3 elements. So is A finite or A is infinite? A is what? Finite. The next is called your infinite set. I know you already know that it's infinite set. I'm going to say next. Which one is your infinite set? Very fast. Follow me very fast. A set is infinite if it contains an uncountable number of elements. So it is uncountable. The element cannot be counted. E.g., the set of all natural numbers. Now, follow me very fast. What are natural numbers? Natural numbers are whole numbers excluding 0. So, in other words, we can say, for example, our set of natural numbers, we have your 1, we have your 2, we have your 3, we have, of course, you can decide to put your 4, 5, 6, 7, 8, 9. A point will come where you cannot just what count, and then it is to what? Infinity. It is to infinity. Are you getting it now? So, these guys here are said to be what? Infinite. So, your finite set, they are countable. Your infinite set, they are what? Uncountable. As simple as that. Number 12, very quickly. Number 12 basic concept. What is it called? It is called family of sets. Family of sets. Family of sets. What do we mean by family of sets? When we say family of sets, it is simple. Take note. A family of sets is a collection of sets. A family of genius, your genius is collection of genius. A family of intelligent people is a collection of intelligent people. A family of lazy students is a collection of lazy students. It is now left for you to determine the family you want to belong to. Are you there with me? Whether you want to move with lazy folks, or you want to move with intelligent folks, or you want to move with people that are serious with themselves, it's not dependent on you. Let's go, guys. Don't play. I'm always saying don't play, as you're going to learn it the hard way. Let's go, guys. It can be finite. So your family of sets could either be finite or it could be what? Infinite. It depends. Take note. For example, your set A, let me say set A, you can say set A there can be your 1, 2, 3. Your set B can be whatever. It can be 3, 5, 7. Your set C there can be, let me say, your 4, 9, 11. So but all of these, what are they? They are what? Family of sets. Are you getting me now? The collection of sets is called what? Family of sets. Now number 13, very quickly, that we're going to look at is called empty sets. Empty set. When we say empty set, what is it? Take note of this very fast, that a set is called empty if it is denoted by this symbol. So this is the symbol for empty set. This is the symbol for empty sets. So one striking thing about empty set is that it contains no elements. Do we have elements in empty set? No, there are no elements in empty set. Okay, you can't go and say, for example, and then take this and then you put dots inside, say this is empty set, they play. It is never empty set. Why? Because in this set there is an element there. And what is the element there? The element there is your what? Dots. Are you getting me now? Empty set contains no elements. Another thing about empty set is that it is the simplest set. So the simplest of all sets, what is it called? It is called an empty what? Set. The next quickly that we must note and understand is known as your what? Your non-empty set. When we say non-empty set, what is non-empty set? That means set that is not empty, right? Okay, let's go. Take note that a set that contains at least, okay, bad, you know, get to, but it has one. A set that contains at least one element is what? A non-empty set. Are you getting me now? This is it. For example, let's say A is equal to, and then you can just say one there. Is this guy an empty set or non-empty set? Non-empty set. Your set B there, we were given set B to be A, B, C. Is it empty set or non-empty set? Non-empty set. Let me say set C, for example, and then we'll now have something of this. You know, somebody will now rush and go and say, no, this set is what? Your set C that we have here, set C is what? Non-empty set, because it contains one element there, and that is dot. Okay, let's say set D, for example. You know, it's very funny. You can see something of this nature in the exam, and then they say something of this. Is this empty set? Oh, but it's inside. It is not. It is empty set. Empty set is inside bracket, so it is an empty set. They play. It contains one element, and what's that one element? The element is this that is inside here. This set D is a non-empty set. Are you there with me? Because it contains an element. Don't play as you learn. Number 15, very quickly, is this. It is called Singleton. or unity set. When they say singleton, it also means what? Unity. Are you getting me now? What do we refer to this as? Take note of this, that a set that contains exactly one element is called singleton set. A set that contains exactly what? One element. What is that set said to be? It is said to be what? Singleton set. Are you there with me? Take note of this. For example, A is, it contains how many elements? Exactly one. We are not saying at least one element now. No. A set that contains exactly one element, and that one element there is 9. This set is said to be singleton. Your set B there, it contains just your I. This set is said to be singleton. Of course, set C, if set C is like this, what is this set? Singleton, one element, exactly one element. Set D, of course, you already know what I want to write, and like this, right? So what set is this? Singleton set, because these are the areas that play around there. Now, the test very quickly, number 16, is called countable and uncountable set. Let's combine the two. What do we mean by saying the set is countable? What do we mean by saying the set is what? Uncountable. This is it very fast. Countable sets are those with elements that can be counted. In other words, you can count the number of elements that are there. That's your countable set. E.g., your natural numbers. Can I count natural numbers? Yes. Natural numbers are numbers that you can count, of course. Despite they range to infinity, if you sit down and you start counting them, there is you can write their value. Are you getting me now? Natural sets, these natural numbers, they start from where? From 1 down to what? Infinity. For 1 to positive infinity, that's your natural number. Now, uncountable sets have too many elements that you can't count them. They have too many elements. E.g., don't play. What is example of your uncountable set? Your real numbers. Your real numbers, they are uncountable. Of course, your real numbers, they contain everything from positive infinity to negative infinity, including 0. They are real numbers. In fact, real numbers contain rationals. Your integers, all of them are inside your real numbers. Are you there with me? So your real numbers even include fractions. They include positive and negative whole numbers. They include decimal, your pi, anything. Think about them at all. They are all inside what? Real numbers. So are they countable or they are uncountable? They are uncountable. There is difference between countable and uncountable sets. Finite and infinite sets. They are two different things entirely, and I've explained them to you. Number 17 quickly here is called your cardinality of a set. Constant question. Cardinality of a set. When they say cardinality of a set, what do we refer to? Understand this with me very fast, that the cardinality of a set is the number of elements it contains. The number of elements contained in a set is called cardinality of a set. What do we mean? Now, it is denoted by, if you see something of this A like this and then it is like this, what does it mean? That is your A is a cardinal set. That means that where A is the set here, the A there is a cardinal set. That symbol, this guy like this, is talking about what? Cardinality. Now, e.g., for example, you can see very fast, they are asking us to get the cardinality of this set, and then I have 1, 2, and then here is your what? Your 3, and then you close the bracket. Now, what is the cardinality of this set? Say cardinality of a set. It is the number of elements contained in a set. So how many elements do we have here? Here is 1, here is your 2, and here is your 3, and then there are 3 elements there. And then somebody will be like, is it because 3 is at the back side, that's why you are using 3? Just they play. Let's say, for example, I have my set B. Set B here is your I, J, K, L, M, N, like this, for example. And then they say, find the cardinality of your set B. What is the cardinality of the set B? The number of elements contained in that set. So here is your 1, here is your 2, here is your 3, here is your 4, here is your 5, here is your 6. So how many elements do we have there? 6. So that is the cardinality of the set. Simple. Number 18 quickly. Number 18 is called disjoint set. When we say disjoint set, so a set could be jointed or a set could be disjointed. Are you getting me now? What do we mean by disjoint sets? It's just like, for example, let me say, okay, for example, let's say your humerus. Okay, let me give it to you. This humerus that you can see here and the femur that you can see. The question is this: humerus and femur, are they jointed in the body or they are disjoint? Of course, they are disjoint because there's nothing that is connecting the two of them together. Humerus is on its own, femur is on its own. Where you have the humerus is in the upper lip, where you have the femur is in the lower lip. Are they jointed or they are disjoint? They are disjoint. Nothing is joining them together. Let's go, guys. This is it very fast. Take note of this very fast, that two sets are considered disjoint if they have no element in common. There is nothing that is linking them in common. Are you there with me? It's just like, for example, let me say you being in Africa, you now that you are in Africa, I'm talking to you that you are in Africa. What concerns you and, for example, the president of America's daughter? What concerns two of you? Are you guys? That means in both of you must rule. What happened? You yourself need to be where? In America. Are you there with me? Oh yes. Oh, simple as that. Don't play. Let's go, guys. Two sets are considered disjoint if they have no elements in what? In common. They have no elements in common. They are said to be what? Your disjoint. For example, let's say if set A, your set A is given to be 1, 2, 3, and set B is 4, 5, 6. What do they have in common? They don't have anything in common, right? Since they don't have anything in common, what do we say they are? Disjoint sets. Are you there with me? Well, we'll get to Venn diagram. I'm going to show you a lot of lovely stuff there. We are full of watch the classes so that you get to Venn diagram very fast. Number 19 here that you must know. We are going to 20 of them. Number 19 is called infinity. Infinity. What do we mean by infinity? This is it very fast. Infinity, this is the symbol for infinity. The love I have for you is infinity. Oh, you are sweet. And I'm saying, oh, you are so sweet. Guy will never call you for 3 days. Let's go. Infinity is a concept that represents an unbounded or limitless quantity. So infinity represents unbounded or limitless quantity. Are you there with me? Such as the set of unnatural numbers. Unnatural numbers, infinity. It is to infinity. But despite natural numbers are to infinity, are they countable or they are uncountable? They are countable. Are you there with me very fast? That's it. Now, number 20, very quickly, it has a name. Number 20 is called your trivial partition. What do we mean by trivial partition? That's number 20, which is the last. Oh shit. What is trivial partition? Take note of this very fast. That a trivial partition is a partition of a set into itself. You are trying to partition one set into itself. That's called trivial partition, where each element is in its own subset. I'm going to explain this to you now. This is it very fast. For example, the set A. Your set A is given to be 1, 2, 3. Now, it can be trivially partitioned as put every set on its own. Put everything, let everything belong to itself. That's as 1, your set A is 1, comma. Another set there, your 2. Are you seeing it now? And then we have another there, 3. What do we call this? It is called trivial partition, where every set is in itself or it's in its own. This is your what? Trivial partition. So these are the 20 basic concepts of set theory that is expected of you to note. Go over this class again and again and again and ensure that you know the whole 20 of them. Don't play. If you have any question, feel free and ensure that you are asking all your questions. Just communicate with us directly. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.